Welcome to VPC Service Controls Testing. Welcome everyone. Today we're going to tackle a critical security challenge that many organizations face after experiencing a data breach. Picture this scenario. Your company just went through a data exfiltration incident. The security team is now mandating VPC service controls to lock down access to sensitive environments. But here's the catch. You need to test these new policies in production without breaking existing services. This is exactly the situation we're addressing today. We'll explore how to safely implement and test VPC service controls using dry run mode, which allows us to evaluate policy impact without actually enforcing restrictions. By the end of this presentation, you'll understand the 4 different approaches available and why one particular method stands out as the best practice for this scenario. Understanding the challenge. Here's the challenge we're facing. After a data breach, organizations typically face intense pressure to implement security controls quickly. VPC service controls are Google Cloud's answer to preventing data exfiltration by creating secure perimeters around sensitive resources. However, implementing these controls in production is like performing surgery on a beating heart. You need to be absolutely certain that your new policies won't break critical business operations. This is where the challenge becomes really interesting. You have a production project with live services, users depend on it, and you need to test how new security policies will behave without actually impacting those services. The key insight here is that we need a way to simulate policy enforcement, to see what would happen if we applied these restrictions, without actually applying them. This is exactly what dry run mode provides. VPC service controls architecture. Before we dive into the solution, let's understand how VPC service controls work architecturally. Think of them as creating a secure bubble around your Google Cloud resources. The diagram shows the basic architecture where we have a service perimeter that acts like a firewall for Google Cloud APIs. Inside this perimeter, your resources can communicate freely, but any attempt to access protected services from outside the perimeter gets blocked. The key components here are the service perimeter, which defines the boundary, the protected resources, like your production project, and the access levels, which define who and under what conditions access is allowed. What makes this powerful is that you can define these perimeters at the organization level and then assign projects to them. This gives you centralized control over data access patterns across your entire cloud infrastructure. Exploring our options. Now let's examine the 4 approaches we have for testing these policies. Each approach has different implications for where we define the service perimeter and what mode we use. The first 2 options involve creating service perimeters directly in the production project. The difference is between dry run mode, which simulates enforcement, and enforced mode, which actually blocks traffic. The second 2 options involve creating organization-level service perimeters and then adding the production project to them. Again, we can choose between dry run and enforced modes. The critical insight here is understanding the difference between these scopes and modes. Project-level policies are simpler but less scalable. Organization-level policies provide better governance but require more careful planning. And the mode choice, dry run versus enforced, is what determines whether we're testing or actually implementing the restrictions. Let me explain why option 1 is the winner. Specifically, the first option, dry run mode with a new service perimeter in the production project, is the best choice for this scenario. First, it's non-disruptive. Dry run mode logs what would be blocked without actually blocking anything. This means you can safely test in production without risking service outages. Second, it provides comprehensive visibility. You'll see every API call that would be affected, giving you detailed insights into potential impacts before you enforce the policies. Third, it's easily reversible. If you discover issues during testing, you can simply modify or remove the policy without having caused any actual disruption. The organization-level options, while more scalable long-term, introduce additional complexity and require broader coordination. For testing purposes, Starting at the project level gives you faster iteration and clearer feedback. Implementation steps. Let's walk through the actual implementation steps. I'll show you the exact commands and configuration needed to set this up. The process involves several key steps. First, we enable the necessary APIs, then create the service perimeter configuration, apply it to our project, and finally monitor the results. Each step builds on the previous one, and I'll show you the specific G-Cloud commands you'll need. The beauty of this approach is that it's all reversible. You can test, analyze, refine, and test again until you're confident in your policy configuration. Pay attention to the policy syntax. The way you define which services are protected and what access patterns are allowed is crucial for getting the behavior you want. Step 1. Enable required APIs. First things first, we need to enable the Access Context Manager API. This is the service that manages VPC service controls in Google Cloud. The command shown here enables the API for your current project. Make sure you are authenticated and have the right project selected before running this. After running this command, it may take a few minutes for the API to be fully available. You can verify it is enabled by listing your enabled APIs or by checking the console. This step is essential because without this API enabled, none of the subsequent commands will work. It is like trying to use a service before installing it. Step 2. Create access policy. Now, we create the overall access policy. Think of this as the top-level container that will hold all our service perimeters and access levels. The command shown creates a new access policy for your organization. The title can be whatever makes sense for your organization. I have used Production Security Policy as an example. This command will return a policy ID that you will need for the next steps, so make sure to save it. It typically looks like a long numeric string. The access policy is organization-wide, even though we are going to use it for project-level testing initially. This gives us room to expand the policy to other projects later if needed. Step 3. Create service perimeter. Here is where the magic happens. We create the actual service perimeter that will define our security boundary. This command creates a new service perimeter in dry run mode. Notice the perimeter type equals dry run parameter. This is crucial for our testing approach. The restricted services list defines which Google Cloud APIs will be subject to the perimeter controls. I have included some common ones here, but you should customize this based on your specific needs. The resources parameter specifies which projects are included in this perimeter. Replace your project ID with your actual production project ID in dry run mode. This perimeter will log all access attempts that would be blocked, but will not actually block them. This gives us the visibility we need for testing. Step 4. Monitor and analyze. Once your service perimeter is active in dry run mode, the real work begins, monitoring and analysis. The monitoring command shown here queries cloud logging for VPC service controls dry run violations. These logs show you exactly what would be blocked if the policy were enforced. You should run this monitoring continuously during your testing period. I recommend letting it run for at least a week to capture different usage patterns, weekday versus weekend, business hours versus off hours, etc. Pay particular attention to the source and destination information in the logs. This will help you understand which services or users would be affected by the policy enforcement. Use this data to refine your perimeter configuration before moving to enforced mode. Understanding the monitoring output. Let me explain what you'll see in the monitoring output. The logs are quite detailed and provide valuable insights into your application's behavior. Each log entry represents an API call that would be blocked by the service perimeter if it were in enforced mode. The key fields to focus on are the service name, the method being called, and the source of the request. The violation type field will typically show VPC service controls violation for requests that would be blocked. The resource name shows which specific resource was being accessed. Most importantly, look at the patterns in these violations. Are they from legitimate business operations that need to be allowed? Or are they potentially risky access patterns that should indeed be blocked? This analysis phase is critical. It's where you'll discover the real-world impact of your security policies before they affect your users. Next steps after testing. After you've completed your dry run testing and analysis, you have several paths forward depending on what you discovered. If the dry run showed no significant issues, you can confidently move to enforced mode using the update command shown here. This switches the perimeter from logging violations to actually blocking them. If you discovered legitimate traffic that would be blocked, you have options. You can create access levels that allow specific conditions, modify the perimeter to exclude certain services, or adjust the project scope. The beauty of this approach is that you have real data to make informed decisions. No more guessing about the impact of security policies. Remember, you can always switch back to dry run mode if you encounter issues after enforcement. This gives you a safety net during the transition. Best practices and recommendations. Let me share some best practices I've learned from implementing VPC service controls in production environments. First, always start with dry run mode, even if you think you understand all the traffic patterns. Applications often have dependencies that aren't immediately obvious. Second, test during different time periods and load conditions. Usage patterns can vary significantly between peak and off-peak hours. Third, coordinate with your development and operations teams. They may be aware of planned changes or unusual traffic patterns that could affect your testing. Fourth, document everything. Keep track of what violations you see, what you decide to allow or block, and why. This documentation will be valuable for future policy changes. Finally, consider implementing policies gradually. You might start with less critical services and gradually extend to more sensitive resources as you gain confidence. Summary and conclusion. Let's wrap up with a summary of what we've covered today. We started with a realistic scenario, implementing VPC service controls after a data breach, while maintaining production service availability. We explored 4 different approaches and identified that dry run mode with a new service perimeter in the production project provides the best balance of safety, visibility, and simplicity for testing purposes. We walked through the complete implementation process, from enabling APIs to monitoring violations and analyzing results. The key takeaway is that VPC's service controls provide powerful security capabilities, but they require careful testing and analysis to implement successfully in production environments. With the dry run approach, you can safely test these policies without risking service disruptions, giving you the confidence to implement effective security controls that protect your sensitive data without breaking your business operations. Thank you for your attention, and I hope this helps you successfully implement VPC service controls in your own environments.